In the previous video, we've seen that when given the parametric equations, we can work out the speed by using this formula. So when you read this, the ds bit is really the distance traveled along the actual path. So ds is the actual distance traveled along the actual path, and then dt is over a period of time. So when you look at this, this is a distance traveled along the actual path, and then this is a time over that period of time. So ds by dt represents the speed. So the speed can be, we can use this to work out the speed of this, and we've seen that in the previous video. So in this video, we're going to work out the speed traveled along an ellipse. So suppose you're given an ellipse like this. Let's say you're given the parametric equations here, and let's pretend you didn't know it's an ellipse. So we would use this here. We would make use of this to so when you look at this, if you square both sides, looking at this, square both sides, that will then give you this, and then looking at this, square both sides, and that will then give you this. So we're going to try to make use of this. So divide both sides by 4, that will then give you this. So sine squared equals this, cos squared equals this. Now if you add both sides, that will then give you this. That will then this whole thing here will become this. So from here you should recognize that this is really an ellipse, because an ellipse is of this form here. So from here you can recognize it's an ellipse. So hang on. So given this here, you can actually plot it as well. So given the parametric equations here, when time equals 0, x will be, this whole thing here will be 0, and this whole thing here will be 1. When time equals 2 pi, this whole thing here will be 2, and then this whole thing here will be 0. When time equals pi, x will be 0, y will be negative 1, and so on. So when given the parametric equations here, you can draw the actual path. So when time is 0, your starting point will be here, because when time is 0, x is 0, y will be 1. So when time is 0, x is 0, y will be 1. So that would be right here. Okay, so this is your starting point when time equals 0. When time equals pi over 2, x will be 2, y will be 0. So x would be 2, x would be 2, y would be 0. So that must be right here. So you can see that the particle is traveling along this direction here. You can see it's traveling clockwise. And then if you extend it, if you look at this and extend it, if you look at this whole thing here, it will trace out this path here. Okay. So if you want to know the speed, then make use of this formula here. So if you want to know the speed, then looking at this, you need to differentiate this, and then you need to differentiate this. So that will then give you this. And then square this. That will then give you this. Blah blah. The ds by dt will be given by this. Okay. And so the speed will be given by this.